Bismillahirrahmanirrahim. Sallallahu alayhi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the important concepts of sketches of trigonometric functions. An important advice: be cool. Sketches, basic functions. These are three basic functions: sin x, cos x, and tan x. The sketches of these functions can either be drawn manually or by using the calculator. You can do any way. Important points. Number one, always remember to label the axis. Must label x-axis and y-axis. If we have to sketch sine theta, then must label horizontal axis with theta and vertical with y. Make sure you label the axis correctly. Number two, take same widths on the axis. This means you must take same widths on this axis and on this axis. If this is 90, this should be 180 and this should be 270. If this is 1, then this should be 2 and this should be 3. Well, number three, draw a proper curve sketch. To draw the proper curve sketch, you should hold the pencil from the top. If you hold the pencil from the top, then you will be able to sketch the curve properly. Calculate the intervals width using the following formula. Interval width means this width. This means interval widths. So you can calculate or find these widths with the help of this formula. Period upon 4. If you have to sketch sine theta, then its period is 360. So 360 upon 4 will give you interval width, which is 90. So you have to make intervals of 90, 180, 270, 360. So with the help of this formula, you can calculate the width of the intervals. While sketching, never change the given domain. This means if this is the domain, for example, if you have to sketch sine theta for this domain, then you have to sketch it for this domain only. You cannot change this domain. Whatever the domain is given in the question, it will remain unchanged. Make sure that you will not change the given domain while sketching the functions. Number 6, calculate the period. Period means cycle of the given function. For example, if we have sine bx or cos bx, then we can calculate the period of this function with the help of this formula and this function as well. This formula is common for both sine and cos. 360 upon b in degrees and 2 pi upon b in radians. For tan bx, the formula is 180 upon b. In radians, it's pi upon b. For example, if you have to sketch this function y is equal to cos 2 theta, then you have to check the period of this function. 360 upon 2, 180. So interval width will be p upon 4. That means 180 upon 4, which means 45. So if we have cos 2 theta, then first we need the period, and then with the help of this period and this formula, we can get the width. So we have to make the intervals of 45 width. Sketch the given curve according to the given domain. Whatever the domain is given, you have to sketch the curve for that domain only. Join the consecutive points by means of a smooth curve. If we have these points, then we have to join these points by means of a smooth curve. For a proper smooth curve, use a sharp pencil for the sketches and hold the pencil from the top. Number 10, for the negative coefficients, draw inverted curves. For example, if you have to sketch minus 2 sine x, then you have to sketch the inverted curve. This is the curve of sine x, positive sine x. For negative sine x, this will be inverted like this. Be careful about the power of the functions. It is more convenient to construct a table for the values of the given power 2 function by using the calculator. If you have to sketch this function, then you should use a table. Construct the table and then sketch the function. Be careful regarding the mode of the calculator. If the given domain is in radians, then your calculator must be in radian mode. For two sketches on the same diagram, draw the complicated sketch first and then draw the easy sketch later. In case of a straight line function, construct the table of the function according to the given domain. For example, if we have this line, and if this is the domain, then we have to make a table. X, Y. We need the first value, the last value, and the middle value. So when we will substitute 0 here, we'll get 1, pi, 0, 2 pi minus 1. So in case of straight lines, always construct the table according to given domain and then draw the line. Sketches. Examples. Y is equal to sine x. We have to sketch this function for this domain. Since this is 1x, so according to this formula, 360 upon b, b is 1. This curve has period 360. Now, see. If you check on your calculator sine 0 and interval width, period is 360, interval width is p upon 4, which is 360 upon 4, so 90. So 90, 180, 270, 360 should be here. And these widths must be same. Now if you check on your calculator sine 0, so sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, sine 360 is also 0. See, we have got these points. You just need to join all the points by means of a smooth curve. This is the standard sketch of y is equal to sine x for this domain. And this means one complete curve, this means period. One cycle means period. And this is the amplitude of the sine function. Amplitude. Amplitude means distance from axis to the maximum point or distance from axis to the minimum point. Since amplitude is distance, so it will always be positive. So you have to take positive 1 here. So if I ask you state the amplitude of this function, then you should write 1 because we have 1 here. And this is the range of sine function. Sine function lies between -1 and 1 inclusive. You should label horizontal axis with x and vertical with y. You have two methods to sketch this function. Number one, you can learn the points for sine function and you can sketch the function. You don't need to mention these points. I just have mentioned these points to make the thing simple so that you can easily understand this. Otherwise, you don't need to mention these points. A small dot is enough. This is just for your conceptual clarity. Cos x. The other way. The first method is you can learn the points and you can sketch the function. The other way is you can use calculator. You can just make the values. You can just make the table for the values of x and y and then sketch the function. You have both the options. Cos x. Well, this is the standard sketch of y is equal to cos x. This one. For this domain. These are standard points of cos. You can learn these points or you can use table. If you check cos 0, it will be 1. Cos 90 is 0. Cos 180 is -1. Cos 270 is 0. Cos 360 is 1. This is here. Must label horizontal axis with x, vertical with y, and this is one cycle. One complete curve means one cycle, means period. The period of this cos curve is 360 degrees, and this is the range of cos curve. Amplitude means distance of the cos curve from the x-axis to the maximum point. This distance is known as amplitude, and this distance is also known as the amplitude from axis to the minimum point. So amplitude is the distance of the curve from its axis to the maximum point or to the minimum point. This is also amplitude and this is also amplitude. But since amplitude is distance, so it must be positive. The amplitude of this function is 1. And this is the range of cos function. This is the standard sketch of tan x for this domain. See, this is one complete sketch. This is one complete sketch. And this is known as period of tan. For tan x, the intervals are of 45 degrees. This is the formula of finding the interval. So these widths are of 45. Since we have to sketch the function for 360, 0 to 360, that is why we have sketched two curves. This is first curve and this is the second tan curve. So these are two tan curves. Well, if you check tan x, if you construct table for x and y of tan, so if you check 0 in your calculator, you will get 0. If you check 45, you will get 1. 90 means infinite. So we must have this dotted line at 90 degree. This is known as vertical asymptote. This must be at 90 degree because tan 90 is infinite. Tan 135 is -1. Tan 0 is 0. See, tan 0 is 0, tan 45 is 1, tan 90 is infinite, therefore tan is parallel to this vertical line here. Make sure you make it parallel. And tan 135 is -1, so we have this point. Tan 180 is 0, tan 225 is 1, tan 270 is infinite. So this is here. Tan 360 is 0 and tan 315 is -1, and this should be parallel to this line. So this is the standard tan curve for this domain. These are two tan curves, in fact, two cycles. This is one cycle. This is the second cycle. Well, the gap between two broken is always period. And we make first broken line at half period, at half p. Period is 180, so this broken line should be at half p. And the second line should be at p. The gap between these two is p. the second line should be at P from this point. Since period is 180, so 90 plus 180 makes 270. The range of tan varies from minus infinite to infinite, and this is the range of tan function. Y can take all real values. You can either write this or this. Note, no minimum, no maximum point, therefore no amplitude in tan function. Sine x. If we have to sketch y is equal to sine x for this domain, then we'll get this curve. We already have discussed this. Sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, sine 360 is 0. So this is the sketch of this function for this domain. See, we took same widths on horizontal axis and same width on vertical axis. What if we have to sketch this function y is equal to minus sine x? So to sketch y is equal to minus sine x, we just need to reflect this curve about the x-axis. If you reflect this curve about the x-axis, you'll get the sketch of this one. This is the reflection of this curve about the x-axis. So whenever we have negative coefficient of sine, we just need to reflect normal sine curve about the x-axis. So we'll get this curve. This is here. Amplitude is always positive. Remember, amplitude of sine is 1 in both the functions, here and here, because amplitude is distance. Changes in coefficients. See, what if we have to sketch 3 sine x? Here we sketch 1 sine x. So we had 1 here and minus 1 here. 1 and minus 1 here. What if we have to sketch 3 sine x? So this should be 3 and this should be minus 3. So this is the sketch of y is equal to 3 sine x. This number should be 3 because this is 3. Minus 3 sine x is very simple. It is the reflection of this curve about x-axis. Amplitude is same for both the functions, 3, because amplitude is distance. Changes in angles. This is very important. Whenever we have different angles, like not 1x, anything except 1x, we have to check the period of the function with the help of this formula for sine and cos. Since we have half x here, therefore we have to find the period of sine x. So we just need to put half here because b is half. So the period of this sine function is 720. Therefore intervals are of 180 degree. So these gaps are of 180. And we have to sketch this function for this domain. So this is the sketch of this function for this domain with this half x and 3. This is 3, so this is 3, and this is also 3 but minus 3 because of this number is below the x-axis. So for this domain we have one complete curve because the period of this curve is 720. These are the standard equations of sine and cos. Now sketches of standard trigonometric equations. First understand these constants. When this is in modulus is known as amplitude for both the equations. This b, we already have discussed this b, this is the coefficient of angle x. This helps us to find the period of the function. C means the axis of the curve. Like if curve is around this line, then this is C. Interval widths, period upon 4, we already have discussed this, and this is the formula of period in degrees, and in radians it's 2 pi upon b. Let's understand how to sketch this function. So this is the mean line, so this is here c, and c plus a is the maximum value of this function because a is positive. So when a is positive, then c plus a is the maximum value of this function y, and c minus a is the minimum value of this function. Remember this is maximum, this is minimum when a is positive, and the curve is like this: c maximum minimum. So range of this sine function is c plus a and c minus a. If I ask you state the range of this function, then you should write y lies between c minus a and c plus a. These equals depend on the given domain. Let's suppose we sketch this function for this domain. Since domain is inclusive, therefore range will also be inclusive. Well, if a is positive, then this is maximum, this is minimum, and if a is negative, then vice versa. This will be minimum and this will be maximum, and this rule is only for power 1 functions. These rules are only for power 1 functions of sine and cos. I'll discuss the power 2 functions rules later. Well, while sketching, never change the domain. Never change this. You should sketch from 0 to 270, this function. So to sketch this function, first compare this function with the standard equation to get the values of a, b and c. A is minus 3, but amplitude is 3 because amplitude is distance. So if they ask state the amplitude, then you should write plus 3. B is 2, C is 1. So now get the period. The formula of period is 360 upon B, which is 2, so 180. Interval width 45 degrees, P upon 4. C plus A and C minus A. C plus A is minus 2, C minus A is 4. Since A is negative, therefore this is the minimum value of Y and this is the maximum value of Y. And the curve must be inverted because of this negative sign. And intervals should be of 45. See, this is the curve. So C is 1. So mean line is here. And intervals are of 45. And since we have to work till 270, that is why we have 270 here. Now see, you have two options to sketch this curve. Number 1 manually, number 2 calculator. So first I'm discussing this manually. We know this is the inverted sine curve. So first point should be here. Second point is this, like minus 2 minimum value. Third point, fourth point, fifth point. If you have learned the points, then you can sketch this function directly. If you don't know these points, if you don't remember where do we put the points, then you should construct the table for the values of x and y. You just need to put this equation in your calculator. So when you will put 0 into this equation, you'll get 1. This is here. At 45 minus 2, 91, 135, 4, 181. This is the one complete curve of sine x, this sine function. Because the period is 180, so this is one curve. This is period. Since we have to work till 270, so we have to draw the later part of this curve. Like we have to sketch this till 270. So at 225 we have minus 2, at 270 we have 1. So this is the way to sketch this type of functions. And these questions are very important. So you have two methods, manually or calculator. For calculator, you can just construct the table for values of x and y, and then make sure you put the right intervals in the table. The intervals are of 45. So first number is 0, second is 45, next is 90. 90 plus 45 makes 135 and so on. You can take the screenshot of this solution because this question is important. See, the curve is smooth because these intervals are constant, same widths, and same width on vertical axis as well. Must label horizontal and vertical axis. And C should be as a broken line. And values like these things should be on x-axis. What if we have to sketch this function 3 cos 2x minus 1 for this domain? So first compare this equation with the standard equation a cos bx plus c to get the values of a, b and c. The amplitude is 3 and since b is 2, so according to this formula period is 180, intervals are of 45, c plus a is 2, c minus a is minus 4. This is the maximum value of y and this is the minimum value of y, and this is the range of this function as well. So this is x-axis, this is y-axis, this is c. So if you are sketching manually, then you know the points of for cos x. This is the standard cos function, this 5 points. So first point is here, second is here, third is here, fourth is here, fifth is here. If you don't know these points, then you need to use calculator. You need to construct a table for the values of x and y. 0, 45, 90, 135 and so on. And you'll get these points from the table. Just need to sketch a smooth curve. Amplitude is 3, period is this, 180. Well, if a is positive, then we always get this type of sketch. And this is the sketch of this function, y is equal to a sine bx plus c, and in this question c is 0. Well, let me write this as c, and this is the question, sine x. A is 1, B is 1, C is 0. That is why we have 1 here and minus 1 here. And if A is negative, then we have an inverted curve like this. So for positive value of A, the curve is normal. For the negative value of A, the curve is inverted. Tan x. This is the standard equation of tan x. When A is positive, we get this sketch. And the mean line is C. This is the mean line. And these are the points for tan x. You don't need to mention these points. You just need to mark a light point and then sketch. This is just for your conceptual clarity. You don't need to even highlight the points. You just need to mark the point, small point, and then sketch the curve like this, a small point. So when A is positive, we get this tan function, and the range is minus infinite to infinite. When we have negative, then we have an inverted curve. This will be here and this will be here. And these are not the maximum and minimum values for tan, because in tan, minimum is minus infinite, maximum is infinite. These values help us to sketch the function. Like at 45, we have c plus a. At 135, we have c minus a. Range of both the functions are same. Y can take all real values. What if we have to sketch this tan function for this domain? Number one, we have to compare this with the standard equation, this equation, to get the values of a, b and c. Since a is positive, so we have to sketch a normal tan function. C plus a, c minus a, this is mean line, period. Because of this half, period is 360, intervals are of 90 degree. So this is c, this is y-axis, this is x-axis, and the intervals are of 90, so we have 0, 90, 180, 270, 360. If you know the points of tan, then you can easily sketch this curve manually. If If you don't know the points, then you just need to construct the table for the values of x and y. So 0 is minus 1. When you will put 0 into this equation, this one, then you'll get minus 1. When you will put 90, you will get 1, and so on at 180 infinite. That is why this curve is parallel to this vertical line, and this is parallel to this. This is the standard tan curve, this tan curve for this domain, and the range of this tan curve is minus infinite to infinite, which can be written as y can take all real values. Take the screenshot of this solution because this question is very important. What if we have power 2 functions? If we have power 2 functions, then it's better to construct table to sketch the function like this. But while constructing the table, make sure you take this power as common power, like sine x whole power as the whole power. This will help you to construct the table, because when you will put 0 here, then sine 0 is 0, so minus 3 plus 2 makes this is 0, so 2. When you will put pi by 2 here, then sine by pi by 2 is 1, 1 square is 1, so minus 3 plus 2 makes minus 1. When you will put pi here, sine pi is 0, so 2. And this is the range of this function, minus 1 to 2. And this is the sketch of this function for this domain. You can also get the range with the help of this formula. For power 2 functions of sine and cos, this is the range of sine and cos when a is positive. C is minimum, C plus is maximum. C, this is the minimum value, which is C. Since we have negative sign, therefore this is the maximum value, and C plus A is minus 1, which is minimum value. Let me label this. This is C and this is C plus A. So when A is negative, then this is the range. C plus A minimum, C maximum, and we had this thing here. This is C plus A and this is C. So you can directly write the range of this function without sketching the function with the help of these formulas. So remember, when we have power 2 functions of sine and cos, and when A is positive, then this is the formula of the range of sine and cos both. And when A is negative, then this is the formula of the range for both. Well, we use sketches to solve some important equation or some standard equation, you can say. So we use sketches to solve this equation, and this equation. In fact, we use sketches to solve these equations, minus 1, 0, 1 of sine and minus 1, 0 and 1 of cos. So when we have sine theta 1, sine theta 0, sine theta minus 1, then we use the sketch to solve these equations. Because sine theta 1 is at 90, so the answer is 90. See the importance of the sketch. When sine theta is 0, then we get 3 answers: 0, 180, 360. If you use calculator, then calculator will give you only this answer, 0. Calculator won't give you these answers. That is why we use a sketch to solve these values of sine theta. So when sine theta is 0, then there are 3 answers: 0, 180, 360. When sine theta is minus 1, the answer is 270 degrees. And these sketches are for this domain. We are solving this equation for this domain 0 till 360. This should be theta. This should also be theta, because we have theta here. So sine theta minus 1 is at 270. Your answer is 270. Calculator will never give you this answer. Calculator will give you minus 90. And for this domain, this is the right answer. Cos theta is 1 is at 0 and 360. See, this point has coordinates 360 comma 1. So cos theta is 1 is at 360 and at 0 degree. So two answers. Cos theta is 0 at 90 degrees and 270 degrees. This is 270. And cos theta is minus 1 is at 180. So sketches are helpful to solve these types of equations of sine and cos. For tan, we use sketch only for two values of tan, 0 and infinite. This is infinite. So tan theta is 0 at three values, 0, 180 and 360. That is why we have three answers. And tan theta is infinite for two values, 90 and 270. And we are solving these equations for this domain. Translations and sketches of trigonometric functions. I will discuss this in my next lecture. Good luck, and I hope this lecture will help you to understand the concepts of sketches of trigonometric functions. An important advice: we must be good to everyone. Allah Hafiz.